Okay, we want to optimize the volume of the box with a surface area of 108, and this one has a square base. So because we want to maximize the volume, let's first write the equation of the volume. The volume is, since it's base area times height, base area is going to be x squared, and the height is h. So this is my volume, and I want to maximize this. Okay, the problem is I have two variables, and I can only deal with one at a time. So I have to figure out another equation that involves both of these variables and solve one for the other. And luckily, we're given the surface area of the box. So 108 is 4 times xh plus x squared. Okay, x squared is the bottom. There's only one of those because the top is missing. And then x times h is the side panel. Okay, because the square base, there are 4 of the same kinds of 4xh. All right. Now I can solve for one variable since I only have one h. It'll be much easier for me to solve for h. So h is equal to, if you do some algebra, you get 108 minus x squared over 4x. So what I'm going to do is I'm going to substitute this expression for h up there. So my new v is equal to x squared times 108 minus x squared over 4x. Okay, and that's equal to 27x minus 1 over 4x cubed. And you can figure out why. It's just simple algebra here. All right, now let's think about the dimension of x. What can x be? What is a maximum and what is a minimum? The minimum obviously is 0. Okay, you can have x be less than 0. But the maximum could be, because the surface area is 108, the absolute maximum this could be is square root of 108, right? Then this is square root of 108, here is square root of 108, and the bottom area will be 108. And that'll be the absolute maximum it could be when h is 0. Okay, that's our domain of x. And we want to find the critical number. Find the critical number of this volume function. All right, so then you have to find the derivative. dv dx is equal to 27 minus 4 over 3x squared. Okay, when is this equal to 0, set this equal to 0, and then solve. So negative 27 is equal to negative 3 over 4x squared. X squared is equal to minus 36. So x can be plus or minus 6, but negative 6 is out of domain, and plus it doesn't really make sense to have a negative length for the square base. So x is 6. So this is my only critical number. All right, and we're going to check to see if this x equals 6 gives us a maximum. So we found that x equals 6 was a critical number, and we want to make sure that this gives us a maximum. So there are a few things you can do. You can do the number line where you put 6 and then 0. Here is the square root of 106, and this is slightly bigger than 10. So you can plug in numbers in here and see if it's positive or negative. You can do that. I'm going to do the second derivative test because my first derivative is here. So second derivative is negative 3 over 2x. Okay, cool. If I plug in 6 here, I get a negative number. So v double prime of 6 is negative, which means I have a local max. Max at x equals 6. Cool. And it might be obvious for this example, but you have to check the endpoints. So what is v of 0? The volume, the actual volume, not the derivative, not the second derivative, the actual volume equation that you have here. When x is 0, it'll be 0. And when x is square root of 108, what is it? And then finally, what is my actual volume when x is 6? Okay, so this volume is 0. If you plug this in, you would also get 0. And when x is 6, 6 times 6 times h, you will get, well actually you don't need h because you can plug it into this equation here, you will get 108. It's just a coincidence that the volume and the surface area are exactly the same. Cute. So the volume is maximized when x equals 6, and what is the dimension? Well, because the volume is 108 at that moment, and x squared h is the equation for the volume, we can solve for h. So 108 is equal to 6 squared h, and you will see that h is equal to 3. So the maximum volume happens when the dimensions are 6 by 6 by 3. Okay?